We have other questions.
Hi, Greg. I do have a small question regarding retrying events, especially if order does matter and event A failed. What should I do in an event source system? Because if I took event B and handled it before event A has succeeded, then I kind of messed up my order.
Ah, so yes. Well, sometimes it matters, sometimes it doesn't. So I could give the answer of anytime you're going through a log and you have any failure, you must stop. And this would be materially correct. It also kind of suck, wouldn't it? Yeah. So you failed on this event that was setting the address for one customer, so you can no longer process any customers. This doesn't seem like a realistic answer. So we might want to get more fine-grained in what we stop. Maybe you stop for that one customer, but you keep working for all the others. Maybe if we have other things that we're doing aside from just customers, you know, like inventory management, maybe we continue doing the inventory management. What we'll generally say is this one projection will stop. And we might go to the one step further and say this bucket inside of that projection will stop. Does that make sense?
Yeah, but I should also stop the writes for that.
No. You still allow that to happen. Why not? Remember, we can detect if there's a problem. Under the vast majority of circumstances, there's not going to be any further problems.
Yeah.
Now, don't get me wrong, I might find something like I'm disabling this customer's account, which, yes, if I have a problem on that, I probably want to no longer do transactions for this account. But it's not that this is a global rule. This is something that we would talk about on a per item basis.
Okay.
Does that kind of make sense?
Yeah, it does. Thanks.
The vast majority of these things are, who cares? Vast majority of them, but there will be that 1%, 5% of things where it's like, well, you know, that's actually pretty important there. And we could legitimately lose $50,000 over this. So we might want to spend the hour or two to have a discussion on it.
Okay, yeah. Thanks.
Yep, no worries.
Any other questions? No? Okay. Just for...
Sorry,
there is a question. Go ahead.
Sorry about that. I was trying to, there may be some banging noise. My apologies. I am trying to figure out a way to ask a succinct question, but I'll try with this. So how do you deal with situations where you need to capture events and make decisions based on event logs in a disconnected state? So imagine, an example I like to think about is cruise ships.
Okay. I actually have a ton of experience in this.
Okay, so I think
so
you understand.
What you're getting into is occasionally connected systems. Yes?
Sounds right.
I literally have a couple hours of video talking about this, and I don't mean to cut off your question. It's just that I won't be able to give you a succinct answer.
Like on YouTube? Like what should I look for?
So it's on YouTube, I believe, if you look up Greg Young Occasionally Connected.
Okay.
Also, I've got my class online, and the video is absolutely in the class. If you drop me an email or whatever, I can hook you up with like some promo code or something, or I'm sure we can talk with Adam and put out a promo code for the group or whatever the hell's needed.
Okay, that sounds good.
To be fair, when you start doing occasionally connected, the bigger things that you start running into are when we've lost connection and I'm doing things without you knowing about it and you're doing things without me knowing about it, and now we know about each other again. So basically what we have to do is very similar to what Git would be doing. Okay, do we have any more in Adam?
Yeah.
I can put out a link to that, or you can at the end of this.
Yeah, you can reconvene on the Slack channel, but I'm sure there's a lot more. I just wanted to share kind of like how do you compare a traditional, system? If you're developing, you're used to just doing MVC, 3-layer cake architecture, giant canonical model for everything in terms of tables and third normal form for everything, versus doing a CQRS event source systems, which is, got all the advantages of scalability, but also accountability as to where things came from. You have your breadcrumb trail to find cause and effect. Like
the single biggest difference is in how you think about the system.
Yeah, exactly. So I just wanted to share. I just wanted to share what we kind of do in terms of thinking about systems this way. So I'm going to share the screen, and we can sort of go through. Not desktop one. Here we go. We'll just do this one. So can everyone see that? Does everyone see the traditional system up at the top? If we stretch it over time, we have a registration process. You see a form with fields for name, etc.
Yeah.
The confirmation that you did it, and then maybe a verification step after to insert a code for whatever the email is going to be sent out with. That verification code that you get in your email to verify your account. If you draw that over time, you notice something interesting. At its basic form, what you have is this is basically an insert statement coming in after you hit the button, and then something reads from that table to give you the confirmation message. Later, we have more insert statements that maybe update a column that says whatever the number will be, the confirmation number that's going to be in the email. We don't have to get into the rest of that. However, if you do this with event sourcing, your focus is on the events. So you're storing, like Greg said, the events. So as you register, you have this register event down the lower left corner. And then when you're in the verification part, you're just storing this event with all the information that's pertinent in that event. And that's what you're storing. That's your focus. So instead of having tables be your focus, you're focusing on events. I color-coded the green for the select up above, but you get the same effect with the other model that's used for your confirmation screen. That may be a confirmations view, where you only show the information that you added at that point. And you can have a separate view later on for other purposes, but your focus is this event. Notice that the event actually does exist in the traditional architecture, but we throw it away. We say, like, our users understand what they're doing. I'm registering. However, we go ahead and do something else, insert with maybe a hash of the password, etc. What's important is what the user had, that event name. There's no getters, setters, dumb inserts and updates. It's capturing the name of the intent. So basically we have a register. We have this register here, and we have the same register here, except this one is only in our brains, right? I drew a little brain here. And we throw that really, really important information away by default, which is not good. This is why event sourcing makes sense, but it's a different way of thinking. Basically, I hope that if you take a system and just draw it in for yourself over time, see what's happening in the traditional system, and then see what's happening in the event source system. And see exactly how you design a system differently. You have, your primary concern is not updating a table, it's just storing that event. It can be a file, it can be event store, it can be any number of very easy technical solutions, and you really forego how you might use that information in further steps. I hope that helps people if they look at that. So Greg, I don't know if you want to talk about this type of visualization of taking that CQRS circular architecture, right? CQRS is always kind of called circular architecture because you have this flow, you input data into the system by adding commands, and they succeed and they mark an event and goes out the other side through the views and the read models and back to the UI, and round we go. Well, if you do that, you notice that a circle that's moved through time in space makes this nice, helix or sine wave if you do it in 2 dimensions, right? So you have this input-output flow. This is quite nice to visualize, and I think event sourcing gives a proper check mark to the important things that you did. These things down here are really important. They capture at the core what happened. They're not influenced by any secondary interpretations. They are what happened, period. They're facts. Greg, anything you want to add?
Let me just see if I can get this onto my screen here. You know what? I'll just do it this way. I'll put it in the chat. So with Event Store, this is actually managed through correlation and causation IDs. And if you go and look at this, you can actually see there's visualizations inside of Event Store that actually show you exactly what he's been talking about.
So in other words, there's tooling that's building on this way of working. So the diagram I drew below is built into Event Store to make that visualization of where things got connected.
And to be fair, this is not in any way, shape, or form selling Event Store that you need Event Store to do this. You could build this on your own in a day. It's basically just using correlation and causation IDs.
So I can show that here. Let me see if I can.
Sorry for late arrival.
Okay, let me just check if I can share the screen on this. Greg can talk about it. Share screen. Here it is. Right, so this is what Greg's talking about. Those links show how you can link up those events I was drawing, and if you're using Event Store, you can show those causations being linked together, which is very helpful. Greg, you have it on the screen now. You should be able to talk about it.
Yeah, so what you can see here is we have an order placed, then we have a payment made, then an order completed with an email sent. You can see the timings between things. There's another visualization that I like to use. This is showing you one instance of this thing having run through a flow. What if I could take 1 million instances and put them together? So show me that order placed goes to payment made. Here's the average and standard deviation of time between those. Here's the other paths that can come off of it, for instance, an error. What percentage of them fall into the error versus what percentage of them go to the payment made? So in other words, you're looking at an aggregation of, let's say, 1 million of these processes going through, as opposed to looking at an individual one. In terms of the arrows themselves, they just get larger and smaller depending how many of them go through.
Any questions about correlation causation IDs I know that a lot of the work that came from event sourcing and CQRS came from like the high performance systems where you had a lot of transactions, you had you know, scalability issues, you know, trading systems. I think the opposite end of the equation where you're just dealing with a new system, etc. There's what we found out at those high intensity, high temperature places is we boiled out the essence of information systems. And Greg doesn't give himself enough credit of just how much insight into state management he gave and how important that is no matter the size of the project. So a lot of the CQRS and event sourcing stuff, as you can see from Greg's presentation, comes from these places that require it because it's the only thing that'll work at that scale. But that doesn't mean it's not applicable at where it's quote unquote not needed. It actually gives you a really good audit of what you're doing. It gives you a very fast way to start because your initial concerns are really just about writing down an event. You're not bringing in a whole technology of which database you're going to use, etc. You're just writing down a statement of fact. And that in itself is incredibly powerful because from there you can make the projections onto anything. And that's kind of like a really strong pillar of architecture for information systems, where you're showing the importance of pieces of information. You're not letting the tooling guide you to take shortcuts where you may not give that same attention to that piece of data. Those facts, the fact that you derive other pieces, other views are very important. I know there's a number of people here that are not new to event sourcing. They're just here because they want to maybe learn a small thing. And I think for the people that have been around for a while, they're seeing that advantage as well. I think for a lot of people that are experienced, especially large banks, et cetera, they only look at it from the CAP theorem perspective, the, you know, no downtime, the really quick spin ups of new versions of read models. Those are very, very important, but it's really important to see that these principles help you through any project. Even if you're doing a small project, if you get good at thinking this way, which is not really something you have to get good at. It really is about being used to thinking in a different way. You'll notice that you can go a lot faster by keeping focus on the important things that you're storing facts. Greg, anything you want to add to that, for like in terms of after 12 years, what you've learned?
So I was just asking, what is correlation ID and causation ID?
Oh yeah, go for it. Explain that.
So correlation ID and causation ID are really, really simple. It's basically when you are making a message and you are doing it in context of another message. So someone sent you a command and now you're raising an event would be a perfect example. You copy the correlation ID of the message that you're responding to, and your causation ID is the message ID of the message that you're responding to. What that allows you to do is to draw graphs like these of how messages interacted with each other.
So I have a easier to understand example that for you can talk to about causation and correlation ID. Hopefully you can. This is one you gave a long time ago, Greg. Let me just see if I can stop the sharing here, and I can start the sharing here.
It's one I gave a long time ago. Oh dear, I hope it doesn't involve Allison and taxis and.
No, I don't think so. Let's see. Here, it's the diner. The order slip.
Yep.
And causation correlation IDs are, you know, food cooked, drink made, delivered. How do you tie all that stuff together? Something caused this. The causation ID is, you know, when you first went into the diner and you were identified as someone that's going to dine there, a party of four, if you will, right? So, you know, those are easy ways to explain those concepts, because many things happen in a diner, right? I don't know if you want to, this is a beginner's talk. So I think a lot of times when you're explaining concepts around event sourcing and distributed systems, you use the diner example. So I'm not sure if it's something you want to use.
Yes, although I generally use the diner example more so to show how to do slip-based messaging.
Right.
So basically, we start using routing slips on a document because it
Right.
turns out much better in that way.
Right. So here I have order slips as just a projection of things that affect them, which are events in different systems that are in different swim lanes.
Yep.
So it's called cafe. But I think another thing that we kind of missed talking about how you talk about event sourcing and CQRS to people that are trying to learn it is that it's really helpful to go back and see how these businesses and industries ran before computers, when we had someone sitting at a desk with an inbox and an outbox, and there's people carrying, little or pushing little carts from one department to another, carbon copies. I don't know. What other examples did you used to give?
Oh, there's a whole ton of them. One of my favorite ones is the piece of paper that starts in Department A and moves to Department B, where they staple something else onto it, which moves to Department C, where they staple something else onto it. But the thing that they stapled on in Department B was actually with 3 carbon copies. And Department C takes one of the carbon copies from Department B. And you can literally watch this piece of paper move through this entire process with staples and things being removed.
Mm-hmm.
And you'd be surprised how many systems today actually are well modeled in that way, but have not been thought about in that way for 40 years.
Yeah. Yeah, there's a lot of industries that have been around for, hundreds of years even. You look at insurance and trading, right? How those
You just want to talk about trade tickets.
Oh, like I'm talking about fur trading.
Oh. But trading tickets are actually a wonderful example of that kind of document-based messaging that's since left document-based messaging in most houses.
Mm-hmm. Yeah. So do we have any other questions? Do people have, any kind of issues trying to introduce these concepts to the place where they're working, or any other questions for trying to adopt some of these things? What problems are you, trying to solve? Maybe some problems that you're running into with traditional approaches, where we can look at the same problem with Greg through the eyes of event sourcing and CQRS. Well, let's see if we have any other questions in the chat.
I do have a question.
Mm-hmm. Go ahead.
So when a command has processed and produced an event, if other systems are interested in this event, do they listen to the event directly, or do they listen to the read model of that? Because I see now we have I think the process manager listening to read models.
So that's an event modeling extra step that we force. Mm-hmm. Usually you don't talk about it when you're talking about pure implementation, but what we do is, even when you do have the combination of the little green piece and the gear is something that you could have in some event handler or some reactive piece of infrastructure. But logically, for people that are describing the business, we always split it up so that you always have command, event, read model, just to have cadence for this pattern. Mm-hmm. But especially when you're talking about the gears on the diagram, that usually is an explosion of something that may be quite simple in a lot of these automations. Sometimes you do want to draw it out when where you're literally pulling a table to see if there's entries and you're doing batch jobs. And it depends on your SLA how fast these things can be, but they always decompose into this kind of thing, because even if you're doing nothing and you're just processing the event directly, that is your view. That is still a view of Like, I don't care about anything else. I only care about what I just received. And so your view is literally just that event. And that might be accurate. But we nevertheless reserve a spot for it. So this may seem a little drawn out because we want to have a cadence for the inputs and outputs. You know, your implementation may vary, but on the average, this helps you gather a good metric on how long certain types of event handlers are taking to write, and same thing with command handlers. Certainly, how long certain read models are taking you to write. So for those that are new to this, one of the best advantages from actually running projects by implementing event sourcing is the cadence that you're not leaning on the book of 50 different patterns from enterprise patterns and practices and all the other things. So you always have the same repeating pattern, a command handler, then there's an event handler, which then populates this read model and so on and so on. So it's a really small amount of patterns done over and over again. And that makes software boring, which is good because you want it to be predictable. And you know that if you're talking about a system, you can always decompose complexity into this linear way of thinking about how you slowly transform something into what you want, instead of saying, oh, I'm just going to throw this over to the developers and they're going to solve it magically. This gives you real ownership. One of the first things that made me fall in love with CQRS and event sourcing is just how easy it was actually to understand by business people as opposed to technical people. And that's because the business people didn't bring in all the baggage with all of the tools they've learned in the technical realm. So that's why this stuff always seems to be more easily explainable to business than technical people. And so really in trying to adopt this and learn it, it's you'll find that it's easy to talk about these concepts and remove all technical terminology, but just talk about the information. What is in that event? That you have an event store, an event log that shows what happened in the business. A business person will say, well, that makes sense. Of course we store these things because we did these things. This actually does represent what our business does. Thank you, right? So there's a natural, once you go this route, it's been, you know, for me since 2008 with Greg, I guess it's 12 years now, geez. You know, I haven't really had any urge to go back to the way things were. Having this audit has, you know, made fixing bugs in production a non-issue. There's customer service reps that actually come back with, here's how we found this problem because customers calling in, but we're also going to give you the exact scenario and where to look to fix it. And so bugs and things like that end up taking, you know, 4 hours or less. We really haven't had more time than that spent on any issues. So what Greg's done really is made this way of thinking about systems mainstream. And I think the only reason that it wasn't mainstream and that we veered away from how we used to work in information systems is simply because storage was really pricey. When you look at the first, you know, 5 decades of computing, it was only for engineers and highly technical people that could program, you know, machine language and things like that. It was very esoteric, very engineering only. And to store the same amount of information that you stored in a regular information system was really tough to do, really expensive to do. I always give this example of this IBM hard drive in the 50s, 10 megabytes, you know, it weighed 1 ton, cost $1 million, cost $30,000 a month to run. That was 10 megabytes in 1950, right? So, and you're running a multinational firm, and someone says, we can't normalize everything. We need old records to be online as well. And they said, forget about it. I'm not buying another one of those hard drives. Right? So we have to realize where we come from. And that's why Greg says, I'm speaking for you here, Greg, that, you know, these are not new concepts. In fact, these concepts predate computing. They're information system concepts.
Oh, and Adam,
Yeah.
you just mentioned some of the problems of languages, and si vous avez des questions en français, ça marche aussi.
No, I don't think that's possible, Greg, because there's not enough French people here.
All I did was say in French, if they have questions, they can put them in French.
No, I know, but I don't think we have enough French people. Augustine asks, does event sourcing make sense for small projects? Well, from my perspective, before Greg answers, I do everything with event sourcing. And I also argue that CQRS can be done implicitly. So you have this materialized view. Well, guess what? That first thing Greg said, to read all the events, you can do that. Your read model could actually be implemented when it becomes really painful to replay all the events. And then it's just really realizing that the read model is caching that query and making it a live report instead. It's still the same logic and still the same view of state. So it's a very nice way of thinking about it. If you think about, just like Greg presented everything with event sourcing first, that's what you do. That's the simplest thing. You show a screen, you store an event, everything else falls out of that. So I don't know if you want to add to Augustine's question.
Yeah, I'll add a touch. For me, it's not so much about the size of the project. What I'm more interested in looking at is what are the value provided from the events. I mean, I've worked in things where literally we had less than half a dozen events, but they're massively valuable. I've worked in things where we had hundreds of events and they provided almost no value whatsoever. So what value can you derive from the event that you actually have is really where I'd be looking.